Okay, here we are in section 1.9 of our pre-calculus class, and in this section we want to review distance and midpoint formulas and get a little bit deeper into understanding circles. So again, these are the learning objectives. You should be reading the e-text, kind of looking at the learning objectives, and these are just some additional examples that if we had an in-class class, I would be going over with you and explaining some of the major points in the sections. Okay, so the teaching notes are here that, to find the distance between 2 points, x1, y1, and x2, y2, we have this formula, the distance formula, right? The square root of x2 minus x1 squared plus y2 minus y1 squared. That's pretty easy to see if you use the Pythagorean theorem, so I'm not proving that to you, and you're probably all very familiar with the distance formula anyways. So for example, if I want to find the distance between the points 2 square root of 7, comma square root of 3, that's my x and my y. I'm going to call this guy x1, y1. It doesn't matter if I called this guy x1, y1 or this guy x1, y1. The formula works either way. So it doesn't matter which one you call which. And the second point is minus square root of 7 for x value. The y coordinate is 2 times the square root of 3. So I'm going to call that x2, y2. So just plugging those into the distance formula, you can easily see how that all works. Comes out to be the square root of 66. Sometimes on my math lab they'll want you to put that into your calculator and give it to a certain amount of decimals, but that's the exact answer, square root of 66. The midpoint of a line segment, hopefully that's a familiar formula as well, but the midpoint of any line segment is just halfway between x1 and x2 and y1 and y2. So that's how you get these simple formulas. x1 plus x2 divided by 2 and y1 plus y2 divided by 2. Essentially the average of the two x's and the two y values. So how do I find the midpoint of the line segment with minus 3/4 5/8 and minus 1/4 minus 3/8 as the endpoints? Again, you just take the average of the two x values and the average of the two y values, and there you go. So it's simple arithmetic here. Just be careful when working with fractions. You understand how to work with fractions and you get everything done correctly there. All right, the standard form of the equation of a circle with center at the point HK, so that's my x coordinate, my y coordinate of the center of the circle, and radius r is this guy. Hopefully you're familiar with that as well. If not, that's okay. That is the standard form for the equation of a circle. So it's x minus h quantity squared plus y minus k quantity squared equals r squared. If you have a beautiful equation of a circle like that, you just read off the center as hk, the x coordinate h, y coordinate k, and the radius as r, or the square root of whatever's on the right side. Okay, so let's find the standard form for the equation of a circle with center minus 8, 5, and radius square root of 11. So there's your h and your k, minus 8, 5, and here's your r. So r squared would just be 11. So x minus h is minus 8, so x minus a minus 8, or x plus 8 squared, plus y minus 5 squared equals the square root of 11 squared, or just 11. So that's the standard form for the equation of that circle with that center and radius. Now the general form for the equation of a circle looks like the following. So whenever you see an equation that has both an x squared and a y squared term in it, and no mixed terms, only a lower exponent for x, like d, in this case d times x is how the author wrote it, and e times y, and then a constant, that's the equation of a circle. So unfortunately, to find the center and the radius, you need to put it into the standard form, which involves the technique called completing the square. So we need to probably review completing the square with you. All right, so how do I complete the square? If you take this as a step-by-step process, I'm hoping you won't find it too hard. All right, so what you want to do is combine all the x terms and leave a space to add something, because that's what completing the square is. We got to add something to it. So got the x squared and the minus 3x, and then I have the y squared and the plus 5y together. Combine the x terms and the y terms, and then any other constants move to the right side. So that means add 1 to both sides up here, so I get equals 1. Now I complete the square in each one of these. The way you complete the square is you look at the middle term here. So you have to have the coefficient of x squared to be 1, by the way, and the coefficient of y squared to be 1. But once you have that, then the coefficient of the x by itself, you take half of that. So half of minus 3 is minus 3 halves, and square that. So you take half of minus 3 and square it. Minus 3 halves squared, and you add that. Now if I add that in here, that changes the entire problem. So as long as I add it to the right side as well, I haven't changed the problem. I've just added essentially 9/4, right? Minus 3 halves squared is 9/4 to both sides of the problem. Likewise, I do the same thing with the y squared part of it. Take half of 5, which is 5 halves, square that, and add it. So, and the reason I'm writing it I'm not writing 25/4 or 9/4 here because that tells you how to write it down here as well. So anyways, you take half of the 5 and square that. So 5 halves squared. Since I added it to this side, I also have to add it to this side so as I don't change the problem. So if you want, you can write this intermediate step here. You don't really need to write this 9/4 and this 25/4 because really what you want to do is take it from here and go right to here. So whatever you took half of, that's what this becomes right here. And then you're squaring that. It becomes a perfect square. The reason we do this is this process turns this into what's called a perfect square. So now I have x plus that b over 2 term, that half of that middle term, squared. Same thing as I have here. Y plus 5 halves quantity squared. So these turned into perfect squares, which allow us to read the h and the k from the standard form of the circle right away. Then I just have to simplify my right-hand side to turn it into one constant. So your common denominator here is 4, so you end up with 38/4 or 19 halves. So when you put that into the standard form of the equation of a circle, you get x minus 3 halves squared plus y plus 5 halves squared equals square root of 19 over 2 squared. So you can see your radius is square root of 19 over 2. And your center is 3 halves minus 5 halves. Hopefully that makes sense. That's a process I really want you to be able to do, completing the square to find out the center and the radius of a circle when the equation is given to you in this non-standard form, in the general form.